So I will be talking about how we do remote access at UIB, University of Bergen, and I will focus on remote access in a walk-up environment. So the settings, we have 3 spectrometers at UIB. There's a 500 for solid state, a 600 for routine NMR, liquid state NMR, and a 850, which is for protein network products and other time-consuming experiments. I will focus on the 600 megahertz, which is an advanced NEO running topspin 4.2 and Windows 10. This instrument is in walk-up mode, so no booking is required. The users. Most users are chemists or molecular biologists. We have some external academic users and a few industry users. The largest amount of users, they are students who run the instruments in full automation. They just need a 2-hour training course to be able to use the spectrometers. There's also quite a lot of expert users who have full access to the spectrometers, can use topspin. They typically have knowledge equivalent to a 10 ECTS practical NMR course. The location, NMR is located in a separate building next door to the biology department, but it's a 5 to 10 minutes walk from the Department of Chemistry. And since many of the users are chemists, there is a need for remote access for local users. They don't want to walk the 5 to 10 minutes up and down every day, especially considering the weather we usually have here in Bergen. The data we acquire. Data can be classified as open, limited, confidential, and strictly confidential. The largest amount of data we acquire can be characterized as limited. These data is made available to all NMR users, but it requires authentication to access the data. The data is also limited in the fact that we have restricted access to the NMR room. On the spectrometer, we have one common user account, but each user has individual IconNMR accounts. All users have read access to all acquired data, but they don't have write access. So they can't delete data that has been synchronized to the NMR server. We also do a handful of confidential data. In this case, we have individual user accounts on the spectrometer. There's not an automatic backup, and the user need to encrypt the data before it is transferred to the storage servers. We have also done strictly confidential data, such as metabolomics data, but then it's not using the storage server and it's not using remote access to the spectrometer. So the remote access, the IT department put strict restrictions on how to access the computers on the university network. And generally, only university maintained computers allowed access to the network. The IT department has made a solution to this, which they call Lab IT. Instrumentations are then put on a separate network. This network has limited access to the internet. This Lab IT service also provide remote access to the instruments and storage and backup. Currently, there are 50 instrument labs at the university using this service, and the NMR lab is one of them. Here's an overview of how this looks like. From the university network, you connect to a NMR access server using remote desktop connection. From this server, you again connect further to the NMR spectrometers. Half an hour after the data has been acquired, it is copied to a server. And at this server, all users have read access. We control the access to the access server and the storage server using an interface like this. This is the interface controlling the storage server. We can give users read-only access, or we can give them full access. And typically, it's only the NMR staff that has full access to the data. If you're accessing the NMR lab from outside of the university network, then you need to set up a VPN tunnel to the university network using a two-factor authentication. From the NMR server, we also have access to TeamViewer, which is nice if you want to give Brooker access to the spectrometers, for instance. The solution I will focus on, then we exchange this last RDC, remote desktop combination, with a web interface using IconNMR. So for remote access, we use the built-in web server in IconNMR. We give individual IconNMR users access to log on. Although since the security is based on restricted access to the access server, we could in principle have given all users access to this. I think it's best that I just show you how this works. So now I'm inside the university network, so I don't need to set up a VPN. I open remote desktop connection, connect to the server. So using my own user name and password, I connect to the server. Let's see. So here I can connect further using remote desktop to the 3 instruments, but I can also connect to the 600 megahertz using the web interface. Logging on with my IconNMR user account. And you notice here, it's a little bit slow. So it takes a few seconds to load up the interface. Now I see that there's no job currently on the spectrometer. I select holder number 1. I want to acquire some data. Ads, and here you see you have the same information that you typically have in IconNMR, just a slightly bit different interface. I give the sample a name, select a solvent. In this case, it's a standard sucrose sample, and I acquire some data. Here I can change settings. I can add experiments. I can add another experiment. Add. Close this window, and after a few seconds, it should pop up here. I can submit. Now I see one of the experiments were too long to be a daytime experiment, so I'll just go back, edit, and set this to a night experiment. Save and submit. And then that experiment should also be submitted. And in a few seconds, I will see that it would start going to sample number 1 there. I can log off, close, log out of the server, and then I'm back. So, now it's hanging here. I'm not sure what happened right now. All right, restart. Okay, so in conclusion, the IconNMR web interface works well. It's a sort of familiar user interface for the IconNMR users. Multiple users can submit samples at the same time. Local users at the spectrometer are minimally affected. It took a few seconds delay to load the queue. When this happens, also the local users affected. So the IconNMR on the local computer will be slowed down a little bit. There's a slightly slow response time, and this slows down over time. Advanced IconNMR use is not possible, so you can't edit all parameters in topspin, for instance. The university has also started beta testing Splashtop as an alternative to the remote control we have been using so far. I just got to test this yesterday, and it works very well. So then this part is exchanged with a Splashtop like this. And my experience so far is that it's working, at least. That's it.